Hello, this is a video about section 3.2, which is entitled Intro to Equations. Okay, so what's an equation? An equation is two expressions joined with the equals symbol. Okay, so you're going to see the equals symbol, and that makes it an equation. And the basic idea is to solve an equation, perform operations to both sides until the variable is isolated. Okay? Perform operations to both sides until the variable is isolated. And isolated just means you get the variable by itself. Okay, so your goal here is to get the variable by itself on one side of the equation, and then you're going to have a number on the other side. So for example, you could end up with x equals -3 as your answer. Okay, but you're going to have to perform operations to both sides, so addition, subtraction, multiplication, or even division sometimes. And as long as you perform the exact same operation to each side of the equation, you're going to find that you'll be able to solve the equation. Okay, so let's start with a relatively simple example. Okay, example. The instructions here are solve. Okay, solve. And for example number 1, we're going to take a look at the equation, a pretty straightforward equation. 5 plus x equals 18. 5 plus x equals 18. So remember, our goal here is to isolate the variable. Here the variable is x. Okay, so how do I isolate x? How do I get x by itself? Well, I have to get rid of this positive 5. And I have to do that by performing operations to both sides. And it has to be the same operation on each side of the equation, otherwise it gets it out of balance. Okay, so in particular, on the left side we have a plus 5, and we want to get rid of this. So how do you get rid of a positive 5? Well, you don't add 5 to both sides, but you do the opposite. You subtract 5 from both sides. So if I minus 5 from both sides of the equation, then what's that going to give me? Well, on the left side, the plus 5 and the minus 5 are just going to give us 0. And then we still have a plus x, so 0 plus x. And then on the right side, what's 18 minus 5? Well, it's actually 13, because 8 minus 5 is 3. Okay, so we get 0 plus x equals 13. The thing is, though, if you're doing an equation and you get 0, you don't actually need to write it, okay? Because 0 plus anything is anything. So we can just erase the 0 and erase this plus as well. So this actually gets us to our answer, which is x equals 13. And it's up to you whether you want to check these. Most people don't bother to check them. And I'll do a couple examples where I check, but I won't be checking on most of them. So, but if you do want to check, how do you do it? Well, to check, basically what that means is you plug in to the original equation. And you need to see if it's true. If it gives you a true equation, then it's a solution, otherwise it's not. Okay, so what are we plugging in here? We're plugging in x equals 13 into the original equation and seeing if it's true. So if I plug in 13 for x, I actually get 5 plus 13 equals 18. That's the original equation where I just plugged in 13 for x. Okay? And as you can see here, we know that 5 plus 13 is 18, so this is true. So some people like to put a check mark there to show that it's true. Okay, so what does that mean? If you check it like that, then you're going to be 100% sure that the answer that you got is correct. But again, you don't have to check it. Some people like to check, other people don't. But it's going to be it's going to take a bit of work sometimes to check it. So if you don't want to check it, that's fine with me. Okay, but what we say here is x equals 13 is a solution to the equation. Okay, so it's a solution to the equation because when we plug it in, it gives us an equation that's true. Okay, so x equals 13 is a solution. All right, so that's a pretty straightforward equation, hopefully. So let's take a look at another example of a little bit harder one. So problem number 2, example number 2. For this one, we have a little bit more stuff going on. So this one is 7z equals 18 minus 32. 7z equals 18 minus 32. So the trick here is on the right side, we can actually simplify the right side of the equation, and we want to do that first before we do anything else. Okay, so let me write that down in words. So distribute and combine like terms first. Distribute and combine like terms first. Now I say distribute, but on this problem we see there's nothing to distribute. On some of the other problems you are going to have to distribute stuff, but for this one there's nothing to distribute. But after you distribute, which there's nothing to do here, you want to combine like terms. So what are the like terms here? We actually have 18 minus 32. So on the right side we can combine 18 and negative 32. All right, and again, if you can't do that in your head, you can write it vertically. So 32 minus 18, but we want to keep the sign of the larger absolute value. So the larger absolute value is negative, so our answer is going to be negative. All right, and then we just subtract. So we borrow from the 3 and it becomes a 2. So we get 12 minus 8 is 4, and then 2 minus 1 is 1. So we get negative 14 for 18 minus 32. Okay, so our new equation here is going to be 7z equals 18 minus 32, we just said, is negative 14. Okay, so 7z equals negative 14. Okay, so we took care of simplifying. So we simplified. There was nothing to distribute, but we did need to combine like terms first. And then for the rest of this problem, we're going to actually have to get rid of this 7. Now, what does 7z mean? Well, like I said earlier, if they don't write the operation, it's automatically multiplication. So this is actually the same as 7 times z. You can put in a little dot there. So what's the opposite of multiplying by 7? Well, to get rid of a 7 like this, 7 times z, the opposite of multiplying by 7 is dividing by 7. And remember, you have to do the same operation to both sides. So if I divide both sides by 7, On the left side, the 7s are going to cancel out, so we just get z, which is what we want. We want to isolate z. And then on the right side, negative 14 divided by 7, well, because there's a minus there, our answer is going to be negative. And then 14 divided by 7 is 2. So we get z equals negative 2. And I'm not going to bother to check that one, but if you were interested in checking it, you would take z equals negative 2, and you would plug in negative 2 back up here in the original problem. So you would get 7 times negative 2 equals 18 minus 32. And then you would simplify each side and make sure it gave you the same number. But again, particularly with the easier problems like this, it's easy to check them. But for some of the later problems, it can be so much work that it's easier to just check your work than to actually plug it back in. Okay, cool. So we're just going to see harder and harder examples to make sure you guys are prepared for the quiz and your homework. Okay, so let's see example number 3 here. Example number 3. Okay, this one is 3 minus 10 equals z divided by negative 4. 3 minus 10 equals z divided by negative 4. So for this problem, what we have is on the left side we need to combine like terms, but we can't combine like terms on the right side because it's actually a fraction. It's actually division there. Okay, sorry, Max is messing up my writing here. My kitty Max. Okay, so on the left side, what's 3 minus 10? Well, they're opposite signs, so we subtract. So we do 10 minus 3 is 7 on the left side. But because the larger number, the larger absolute value was negative, that means our answer is going to be negative. So it's going to be negative 7. Okay, so we have negative 7 equals z over negative 4. Okay. And the reason I keep putting a slash through my z is I don't want it to look too much like a 2. So I want it to be clear that it's a z, not a 2, so that's what the little slash through it means. Okay, anyway, how do we finish this problem? Well, on the last problem that we were looking at, to get rid of a 7z, to get rid of the 7 in the numerator, we had to divide both sides by 7, because the opposite of multiplying is dividing. Well, here we kind of have the reverse situation. Here we have z divided by negative 4. So how are we going to get rid of the negative 4? Well, we have to do the opposite of dividing by negative 4, which is going to be multiplying by negative 4. Okay, so we actually multiply both sides by negative 4. So I'm going to multiply both sides by negative 4. And again, why am I choosing to multiply? Because I see this is dividing by negative 4, and the opposite of dividing by negative 4 is multiplying by negative 4. So I know that these negative 4s on the right side are going to cancel out, and that's going to allow me to isolate z, which is what I want. Okay? So on the right side, the negative 4 on the top and the bottom just cross out, so we just get z. And then on the left side, we have negative 4 times negative 7. So remember, when you're multiplying or dividing, 2 minuses cancel out and make a plus. So those are going to cancel and give us positive, and then we're going to have 4 times 7 is 28. So we get 28 equals z. 28 equals z. And even though it's in the reverse order as to which we usually write it, it doesn't matter. You don't have to have your variable on the left side and your number on the right side. As long as your variable is isolated on one side, it's fine. So in particular, when you see it like this, 28 equals z, that means the same as the reverse order, means the same as z equals 28. So either order is fine. When you're doing your homework, though, they're probably going to write it in the form z equals 28. It's just a convention that most people do is to write the variable on the left and the number on the right. But these two equations actually mean the same thing. They mean exactly the same thing. Okay, cool. Okay, so I wanted to do as many examples of these equations as possible. So that was example 3 that we just did. This is going to be example number 4. So there's new tricks that pop up as the equations get harder and harder, and I want you to see the new tricks. That way you're able to do your homework. Okay, so let's take a look at this next question. Okay, so example number 4 is 5x plus 6 minus 4x equals 15. 5x plus 6 minus 4x equals 15. So here, before we can do anything else, we have to simplify. So we have to combine like terms on the left side. In particular, we've got the 5x and the negative 4x to combine. And then we also have a positive 6 by itself, but we can't combine that with anything. Okay, so 5x minus 4x, well, you keep the variables and you add or subtract the coefficient. So 5 minus 4 is 1. So we actually get 1x plus 6 equals 15. Okay? But remember, if it's 1 as your coefficient, you don't have to write it. So rather than writing 1x, what people do is they actually just erase the 1. Because if you don't write a coefficient, it's automatically 1. So now we actually just have x plus 6 equals 15. And then how do we finish isolating x here? Well, to get x by itself, we're going to have to get rid of the plus 6. And this is adding. So what's the opposite of adding 6 to both sides? Well, it's actually going to be subtracting 6 from both sides. So that's how we're going to get rid of the plus 6 on the left side. So I'm going to go ahead and minus 6 from both sides, because I want to get rid of the 6 on the left side. Alright, so we're actually going to get, on the left side we'll just have x, and then on the right side we get 15 minus 6 is 9. Okay, so we get x equals 9. Alright, and that's actually the whole problem, so that one wasn't actually that bad. Okay, so I wanted to open up a problem where we get to distribute and also combine like terms. Okay, so example number 5. Example number 5. For this example, we have negative 4 times the quantity, negative 2 minus 3z equals 13z. Okay, so negative 4 times the quantity, negative 2 minus 3z equals 13z. And here we can't do anything yet because we actually have to simplify the left side. On the left side, what can we do to simplify here? Well, we have negative 4 multiplied times 2 terms. So what we're going to have to do is we're actually going to have to distribute. Alright, so we're going to distribute the negative 4 to each of those terms. And you have to distribute the minus as well as the 4. And if you can't do all that in your head, if there's too many minuses, you can write it out. So for the first term, we're going to have negative 4 times negative 2. And for the second term, we're going to have negative 4 times negative 3z. Some people can do that in their head, but if you can't, it's not a big deal to write out that step. Oops. Sorry, I dragged the screen off. Okay. That was interesting. Okay. So anyway, what we got here is negative 4 times negative 2 and negative 4 times negative 3z on the left side. Okay, so where do we go from here? Well, remember that when you're multiplying, two minuses cancel and give you a plus. So these are going to cancel and give us positive 4 times 2 is 8. And then also for the second term on the left side, the two minuses cancel out and give you a positive 4 times 3 is 12z. So we actually have 8 plus 12z equals 13z. Okay? 8 plus 12z equals 13z. Now here we have a new situation that we haven't seen before in this class, which is because we have an equation here, we have to get z on one side to isolate it. And the problem is right now we have a 12z on the left side and a 13z on the right side. So what we're going to have to do is we're going to have to either get rid of the 12z or we're going to have to get rid of the 13z. And the way I teach it to people is it's usually easier to get rid of whichever coefficient is smaller. So like here, it's easier to get rid of the 12z than it is to get rid of the 13z. There's nothing wrong with getting rid of the 13z, but it'll be less work if you get rid of the positive 12z. So how do we get rid of a positive 12z? Well, what's the opposite of adding 12z? Subtracting 12z. So we're going to subtract 12z from both sides. Okay, so we minus 12z from both sides. Okay, and notice I have all the z's lined up, so I can easily do this subtraction. Okay, so on the left side, we're just going to have 8, because 12z minus 12z is 0, right? Those just cancel out. Some people cross them out. And then on the right side, well, combining like terms, 13 minus 12 is 1. So we get 1z. So 8 equals 1z. But keep in mind that the 1, you don't write it in your answer. So once again, if you have 1 as your coefficient, you just go ahead and write it as the variable. So we get 8. 8 equals z. So our answer is 8 equals z. Cool. So, and keep in mind in my math lab, instead of writing 8 equals z, they're going to write the variable first. So you would do z equals 8. But they mean the exact same thing. Okay, so that was example number 5. And we've seen a lot of different examples here. So I wanted to just do one more example from this section. Example number 6. Okay, so example number 6 here is going to be sort of everything that we've learned all combined together from this section. So this one's going to be negative 7 times the quantity x plus 4 minus 12 equals 15 plus 8. Okay, so negative 7 times the quantity x plus 4 minus 12 equals 15 plus 8. All right, so this one has a lot going on, I'm not going to lie. But if you remember what I told you, what do you do first? Well, the first thing you do is you distribute. So step 1 is distribute. Distribute. Okay, so we're going to start by distributing this negative 7 to the x plus 4. So if I distribute the negative 7, I have to distribute the minus as well as the 7. So that's actually going to give us negative 7 times x is negative 7x for the first term. And then for the second term, negative 7 times positive 4 gives us negative 28. So we have negative 7x minus 28 minus 12 equals 15 plus 8. Okay, so our first step is to distribute. Second step is to finish simplifying. And how do you finish simplifying after you distribute? Well, you combine like terms. So step 2 here is to combine like terms. So that's what we're going to be doing next. Okay, so what are the like terms here? Well, we see that on the left side we have negative 28 and negative 12. Those are like terms because they both don't have variables, so they're like terms. And then on the right side we also have 15 plus 8. We can combine those. And then on the left side we have a negative 7x, but we can't combine that with anything because there's no other terms involving x. So, so if we're combining like terms here, all we can combine are the constants. So on the left side we're going to have negative 7x, and then with negative 28 minus 12, these numbers have the same sign, so we keep the sign and add. So we know it's going to be negative to keep the sign. And then what's 28 plus 12? Well, you can write it vertically or just do it in your head. It should give you 40. Okay, so we should have negative 7x minus 40. Okay, and then on the right side, combining those like terms, we have 15 plus 8, which is actually going to give you 23. So on the right side we have 23. Okay, so we have negative 7x minus 40 equals 23. And then how do we finish this whole process? Well, your first step is distribute. Second step is combine like terms. Your third step is actually going to be to isolate the variable. Okay, so step 3 is isolate the variable. Okay, so how are we going to do that here? Well, we look at our equation. Negative 7x minus 40 equals 23. And we want to get x by itself. So when you're isolating a variable, you want to actually get rid of things that are added or subtracted first. And then at the end, we'll divide by negative 7. So you don't actually want to divide by negative 7 yet. First, you want to get rid of the negative 40. So how do you get rid of minus 40? Well, what's the opposite of subtracting 40? Adding 40. So what we're going to do is we're going to actually add 40 to both sides. Okay, so if I add 40 to both sides, on the left side we're going to get negative 7x, and then the plus 40 and the minus 40 are going to cancel, so that's just 0. So we have negative 7x on the left side, and then on the right side, we're doing 23 plus 40. Well, 23 plus 40 is actually 63. So on the right side, we're going to have positive 63. All right, and then how do I finish isolating x? Well, I have to get rid of the negative 7. And remember, that's not actually negative 7 plus x. That's negative 7 times x. That's what that means. So what's the opposite of multiplying by negative 7? Like, how do I get rid of that? Well, the opposite of multiplying is dividing. Okay, so to get rid of the negative 7 on the left side, we're actually going to have to divide both sides by negative 7. Okay, so that's going to be our last step. So we're going to divide both sides by negative 7. And you might be wondering, well, why did you divide by negative 7 and not positive 7? Well, I need to isolate x, and that means I have to get rid of the minus. So if I don't divide by negative 7, I'm still going to have a minus left over. So that's why I actually divided by negative 7. So on the left side, the negative 7s just cancel out. The 7s and the negatives both cancel out. So on the left side, we just have x. And then on the right side, we have 63 divided by negative 7. Well, because there's only one minus here, we know our answer is going to be negative. And then what's 63 divided by 7? Well, it's actually 9 because 7 times 9 is 63. So our answer is going to be x equals -9. Okay.